in today's class, let us see some more problems on DIF FFT algorithm. So, the problem is compute the 8-point DFT of the sequence x of n, which is equal to sin pi by 2 n, where the range of n is from 0 to 7 using DIF FFT algorithm. So, what they have done here is they have given us a trigonometric function. First, what I need to do, I need to find out the sequence. Later, I need to apply DIF FFT algorithm. So, we know the range of n. So, let us start giving the values for n from 0 to 7. First, let us find out the sequence and then we will apply DIF FFT algorithm. So, the first value of n be equal to 0. So, if n is equal to 0, x of 0 will be equal to sin 0. If I substitute the value of n as 0, sin 0 is 0. Similarly, let the value of n be equal to 1. If so, x of 1 will be equal to sin pi by 2. So, sin 90 is 1. Okay. Again, if I substitute n as 2, let n be equal to 2. X of 2 will be equal to sin pi by 2 into 2, which is equal to sin pi. We know sin pi is nothing but equal to 0. Similarly, let the value of n be equal to 3. X of 3 will be equal to sin 3 pi by 2, which is equal to minus 1. Let the value of n be equal to 4, the next value of n. So, x of 4 will be equal to sin 4 pi by 2, which is equal to sin 2 pi, which is equal to 0. Let the value of n be equal to 5, which gives us the value of x of 5, which is equal to sin 5 pi by 2, that is equal to 1. So, the next value of n is, let n be equal to 6, x of 6 is equal to sin 6 pi by 2. So, this is nothing but equal to sin 3 pi, so which is equal to 0. The last value of n is 7. If so, the value of x of 7 will be equal to sin 7 pi by 2, which is equal to minus 1. So, what we did? We substituted the values of n from 0 to 7 and we found out the values of x of 0 up to x of 7. Now, let us tabulate these values and let us find what is x of n. If I tabulate all these values, that gives us x of n, which is equal to x of n. What is the first value? It is 0. Second, it is 1. Third, it is 0. X of 3 is minus 1. X of 4 is 0. X of 5 is 1. X of 6 is 0 and x of 7 is 0. So, what we did? We found out the sequence of x of n. Now, to this sequence I need to apply DIF FFT algorithm and I need to find out the DFT for this particular sequence. If I draw the butterfly structure of DIF FFT algorithm, so the input is in normal order. So, here we get the twiddle factor terms. Again, here also we get the twiddle factor term, that is omega 8 bar 0 and omega 8 square. Similarly, at this point we will have omega 8 bar 0 and here we will have omega 8 square, and in the last stage, so here we will have omega 8 bar 0. Again, here it will be omega 8 bar 0. So, here it is omega 8 bar 0 and omega 8 power 0, and we all know the output of DIF FFT algorithm will be in bit reversed order. So, the first value will be x of 0, then it will be x of 4, then it is x of 2, then it will be x of 6, x of 1, x of 5, x of 3 and x of 7. So now we are completely ready with the butterfly structure of DIF FFT algorithm. Now let us tabulate the sequence and let us try to find out the DFT for this particular sequence. So since the input is in normal order, so I will write the sequence. So 0, 1, 0, minus 1, 0, 1, 0, minus 1. Now we are ready with the input of first stage. So let me try to find out the output of first stage. So from this branch the signal coming here is 0, and from this branch also the signal coming is 0. So 0 plus 0 is 0. Again at this point the signal coming is 1, and from this branch also the signal coming is 1, 1 plus 1 is 2. Again at this point here the signal coming is 0, and from this branch also the signal coming is 0, 0 plus 0 is 0. So at this point the signal coming is minus 1, and here the signal coming is minus 1, minus 1 minus 1 is minus 2. And at this point, since the signal coming here is also 0 and this is also 0, the resultant will be 0. So again at this particular point, the signal coming here is 1 and the signal coming here is 1, but this one is multiplied with minus 1, so 1 minus 1 is 0. At this stage, the signal coming from this branch is 0 and the signal coming from this branch is also 0, so the resultant is also 0. Again standing at this point, the signal coming from this point is minus 1. This minus 1 is multiplied with this minus 1, so minus 1 into minus 1 is plus 1. So at this point the values which we have is minus 1 plus 1, which is equal to 0. Okay. So like this we will find out the output of first stage. So what you can do is you can write down the sequence also and you can finally tabulate the value here. So what I am doing, I am just writing the values directly here just by explaining how we are getting those values. So now we are ready with the output. Now let me try to feed the input to second stage. So 0 comes directly here, 2 comes here, 0, minus 2. Multiplying all these zeros with the respective twiddle factor terms gives us 0. So the input to the second stage for all this levels will be 0. Now let us try to find out the output of second stage. So at this particular point the input is 0, the second branch input is also 0, so 0 plus 0 is 0. At this point the input is 2, and from this branch the input is minus 2, 2 minus 2 is 0. So again here the signal coming here is 0 and the signal coming from this branch is also 0, so that gives us 0. So standing at this particular point, here we are getting 2 and this minus 2 is getting multiplied with minus 1, that gives us minus 2 into minus 1 as plus 2, so 2 plus 2 is 4. So what will be the values here? It will be 0, y 0, both the branches are giving 0. Here also the output is 0, y, the inputs are 0. Similarly at this point the output is 0 because the inputs are 0. Again at this point the output will be 0 since the inputs are 0. So now we got the output of second stage. Now let us try to give input to third stage. So this 0 comes directly here, 0 comes directly here, this 0 comes here. So 4 is getting multiplied with omega 8 square, which is equal to minus j. So this gives us minus j4. So rest of the values are 0. So you can just write those things directly. Okay. Now let us try to find out the output of stage 3 with the help of the input values. So since both the inputs of this branch and this branch are 0, the output will be 0. Similarly here the output is 0, whereas coming to this branch the input from one branch is 0 and the other branch is minus j4. So the resultant will be minus j4. So at this particular point this branch is feeding the input of 0 and here this minus j4 is getting multiplied with minus 1, that gives us plus j. So that will be plus j4. Similarly, since here the inputs are 0, the output at this point and this point are 0. Similarly, here this branch is also giving 0, 0, is coming here from both the branches. So 0 plus 0 is 0. Again here both the values are 0, that gives us 0. Now what I need to do? I need to multiply 0 with the twiddle factor term omega 8 power 0, which gives us 0. Similarly, multiplying j4 with omega 8 power 0, which is equal to 1. So multiplying j4 with 1 gives us j4 only. Similarly, 0 multiplied with 1 gives us 0. 0 multiplied with 1 gives us 0. So we are ready with the output sequence, that is x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. So let us tabulate that and let us see what is the sequence of x of k. So we should be careful whenever we tabulate the output, whenever we use DIF FFT algorithm. Why? Because the output will be in bit reversed order. So let us start tabulating. Therefore, x of k will be equal to, what is x of 0? X of 0 is 0. What is x of 1? X of 1 is also 0. X of 2 is minus j4. X of 3 is 0. X of 4 is 0. X of 5 is also 0. X of 6 is plus j4 and finally x of 7 is 0. So this is how we can find out the DFT of a given trigonometric function with the help of DIF FFT algorithm. Now let us see how to find out IDFT with the help of DIF FFT algorithm. The next problem on DIF FFT algorithm is, so first 5 points of 8 point DFT of a real valued sequence is given by x of k, which is equal to 0, 2 plus j2 minus j4, 2 minus j2 and 0. Determine the remaining points, hence find the sequence x of n using DIF FFT algorithm. So what they have done is, first they have given only 5 point DFT, 5 points of 8 point DFT. We need to find out the remaining points and then we need to find out x of n with the help of DIF FFT algorithm. So from the properties of DFT, we all know x conjugate of k is nothing but equal to x of n minus k, or I can write this as x of k, which is equal to x conjugate of n minus k. So what are the values which they have given? They have given x of 0, x of 1, x of 2, x of 3 and x of 4. I need to find out the values from x of 5. For that, let us start giving the values for k. Let k be equal to 5. If so, x of 5 will be equal to x conjugate of the value of n is 8. So 8 minus 5, which is equal to x conjugate of 3. We know what is x of 3. X of 3 is nothing but 2 minus j2. If I take conjugate to that, the value will be 2 plus j2, which is equal to x of 5. So let the next value of k be equal to 6. So if so, x of 6 will be equal to x conjugate of 8 minus 6, that is equal to x conjugate of 2. Okay, what is x of 2? X of 2 is minus j4. If I apply conjugate to that, it will be equal to plus j4. Similarly, what is the last value of k? Let k be equal to 7. So x of 7 will be equal to x conjugate of 8 minus 7, that is equal to x conjugate of 1. So what is x of 1? It is 2 plus j2. If we apply conjugate to that, that will be equal to 2 minus j2. So which is nothing but x of 7. So did we get all the samples? Yes. Now let me tabulate and find out the overall x of k. Therefore, x of k will be equal to 0, 2 plus j2 minus j4, 2 minus j2, 0, 2 plus j2, j4 and 2 minus j2. So what we did? We completed the first question, that was determine the remaining points. We found out the remaining points and completed x of k. Now with the help of this x of k, I need to find out x of n using which algorithm? DIF FFT algorithm. If I draw the butterfly structure for IDFT using DIF FFT algorithm, so this will be the first stage, -1. Again here we need to multiply it with -1. So this will be omega 8 power minus 0, omega 8 power minus 0, omega 8 power minus 0 and omega 8 power minus 0. So the second stage will be a butterfly structure, before which we should multiply omega 8 power minus 0 to the output of this stage, and similarly here it should be omega 8 power minus 2. Similarly here it should be omega 8 power minus 0 and here it will be omega 8 power minus 2. So completing the second stage, so these two outputs should be combined to find out the output of the second stage. Similarly in the bottom part also we are doing the same thing, combining two signals and finding out the output of second stage, and here this has to be multiplied with -1. So this completes stage 2. So moving on to stage 3, before that I need to multiply the output of all these terms with the twiddle factor term, that is omega 8 power minus 0, omega 8 power minus 1, omega 8 power minus 2 and omega 8 power minus 3. So now completing the structure, so I need to combine these two outputs, similarly these two, again these two, at last these two, again these two, but this has to be multiplied with -1, this two, this has to be multiplied again with -1, again these two, and this has to be multiplied with -1. Okay, so again this two, this has to be multiplied with -1. So this is the structure for finding out IDFT using DIF FFT algorithm. Here the input is in which order? Bit reversed order. So if I write the input, it is x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3 and x of 7, whereas the output will be in normal order. So if I write the output, so this will be x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. So before finding out all these things, what I need to do? I need to divide the output of this stage with by n. Okay. So this is the complete structure for finding out IDFT using DIF FFT algorithm. Now what let us do? We have x of k. Now let me tabulate this and let us try to find out x of n. So this will be x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. Okay. What is x of 0? X of 0 is 0, write it as it is. X of 4 is also 0. X of 2 is minus j4. X of 6 is, it is equal to plus j4. X of 1 is 2 plus j2. X of 5 is 2 plus j2. X of 3 is 2 minus j2 and x of 7 is also equal to 2 minus j2. Now we are ready with the inputs. Now I need to find out the output of first stage. Before that, 0 should be multiplied with 1, gives us 0 only. J4 should be multiplied with 1, gives us J4 only. Multiplying 2 plus J2 with 1 gives us 2 plus J2. Multiplying 2 minus J2 with 1 gives us 2 minus J2. Now let us try to find out the output at this point. Since the input fed to this branch is 0, so the outputs of both the output at both the points will be 0. So again coming to this point. So input from this branch is minus 4. From this branch it is plus 4. X of 6 is plus 4. So this branch is plus 4. Minus J4 plus J4 is 0. Similarly coming to this point, minus J4 comes here. So this is getting multiplied with minus 1. So what is the values at this point? It will be minus J4 which gives us minus J8. Again at this point, so 2 plus J2 is coming here, 2 plus J2 is coming here which gives us 4 plus J4. At this point, 2 plus J2 is coming here. This is getting multiplied with minus 1. So what is the value at this point? It will be 2 plus J2 minus 2 minus J2. So the resultant will be 0. Again at this point, 2 minus J2 is coming here. Again 2 minus J2 is also coming from this branch which gives us 4 minus J4. Whereas coming to this point, this is getting multiplied with minus 1. That gives us minus 2 plus J2. And it is getting added to plus 2 minus J2. Therefore, the resultant will be 0. We are ready with the output of first stage. Now, let us give input to second stage. So, 0 directly comes here. This 0 comes here. This also comes here. So, minus J8 getting multiplied with plus J gives us minus J square 8. We know J square is nothing but equal to minus 1. So, minus 8 into minus 1 is plus 8. Similarly, this comes directly here. This also comes here. So, multiplying this with 1 gives us the same value 4 minus J4 and finally 0 multiplied with J gives us 0. We got the inputs to second stage. Let us try to find out the output of second stage. So, standing at this point, both the branches are giving the input as 0. So, the output will be 0. At this point, one branch is giving the input as 0. The other branch is giving it as 8. So, 0 plus 8 is 8. At this point, both the inputs are 0. So, the output is also 0. At this particular point, the input from one branch is 0. The input from other branches 8 into minus 1 is minus 8. So, the resultant is minus 8. So, standing at this point, this branch is giving us 4 plus J4 and this branch is giving 4 minus J4. So, plus J4 minus J4 gets cancelled. So, the resultant value is plus 8. At this point, the output will be 0. Why? Because the inputs are itself 0. Again at this point, one input is 2 plus J4, the other input is 4 minus J4 multiplied with 1 which becomes 4 plus J4 minus 4 plus J4. Therefore, plus 4 minus 4 gets cancelled. So, the resultant here will be J8. At last, here since the inputs are 0, the output will be 0. So, we got the output of second stage also. Now, let us try to find out the input to third stage, finally the output of third stage. This 0 comes directly here, 8, 0, minus 8. 8 getting multiplied with 1 gives us 8, 0 multiplied by anything is 0. Again J8 getting multiplied with J gives us J square 8. We know J square is nothing but equal to minus 1. So, this becomes minus 8. So, 0 multiplied by anything is 0. So, we got the inputs of third stage. Let us try to find out the output. So, at this particular point, this branch is giving the input as 0 and this branch is 8. So, 0 plus 8 is 8. Again at this point, input is 8 and from other branch it is 0. So, 8 plus 0 is 8. Again this is giving 0 and this branch is giving minus 8. So, that gives us minus 8 itself. Again here one branch is giving us minus 8 and the other branch is giving 0. So, the resultant is minus 8. So, coming for the next point here, this is giving us 0. 8 multiplied with minus 1 gives us minus 8. 0 minus 8 is minus 8. Again at this point, 8 minus 0 gives us 8. Here it is 0, minus 8 into minus 1 is plus 8. So, 0 plus 8 is 8. Here it is giving minus 8, minus 0 is minus 8. So, we got the output, but What is the last part? I need to divide all these terms by n. So what is the value of n? They are telling us to find out 8-point DFT. So the value of n is 8. So dividing this by 8, x of 0 is equal to 1. By 8 gives us 1. So this gives us minus 1. Minus 8 divided by 8 is minus 1. Minus 8 divided by 8 is minus 1. 8 by 8 is 1. 8 by 8 is 1. Minus 8 by 8 is 1. So this is how we can find out the IDFT of any given sequence with the help of DIF FFT algorithm. Now we found out this output. Now let me tabulate those things in order to get the final sequence, that is x of n. Therefore, x of n is equal to, what is x of 0? It is 1. X of 1 is also equal to 1. X of 2 is minus 1. X of 3 is minus 1. X of 4 is minus 1. X of 5 is 1. X of 6 is 1. X of 7 is minus 1. Like this, we can find out the IDFT for the given sequence with the help of DIF FFT algorithm. So now we understood how to find out DFT and IDFT both by using DIT FFT algorithm as well as DIF FFT algorithm. Now let us try to combine these two things and let us try to find out the solution in the next problem. The next problem is, let x1 of n be equal to 1, 1 by 2, 1 by 4, 1 by 8. x2 of n be equal to 1, 1, 1, 1. Compute the DFT of x of n by DIT FFT algorithm. So this is important. And that of x2 of n, that is I need to find out the DFT of x2 of n by using DIF FFT algorithm. Then using the above results, evaluate the circular convolution of x1 of n and x2 of n. So what I need to do first, I need to find out the DFT of x1 of n with the help of DIT FFT algorithm. Then I need to find out the DFT of x2 of n with the help of DIF FFT algorithm. At last what I need to do, I need to combine the solution from these two results. Then I need to compute the circular convolution of x1 of n and x2 of n. Okay. Now looking into the given data, how many samples we have? 4. So the value of n is equal to 4. If the value of n is equal to 4, if I express this in the form of 2 power v, it is nothing but 2 square. Therefore, the value of v is nothing but equal to 2. So it tells that we should have how many stages? 2 stages. So if I draw the butterfly structure for DIT FFT for n is equal to 4, it looks like this. So it will have how many lines? We will have 4 lines. So the first structure and again here we need to multiply this with minus 1. Again here we will have minus 1. So the second stage, combining these two inputs, these two and these two, this has to be multiplied with minus 1 and minus 1. Here we all know the computation of DFT using DIT FFT algorithm, the input will be in bit reversed order and the output will be in normal order. So input I am writing in bit reversed order, x of 0, x of 2, x of 1 and x of 3, and this has to be multiplied with omega 4 power 0 and x of 3 value should be multiplied with the twiddle factor term. Similarly, the resultant of this stage has to be multiplied with omega 4 power 0 and omega 4 power 1. Okay. Now let me tabulate the values. So this is x of 0, x1 of 0, x1 of 1, x1 of 2, x1 of 3. So all this becomes x1 of 0, x1 of 2, x1 of 1 and x1 of 3. What is x1 of 0? It is equal to 1. x1 of 2 is 1 by 4. x1 of 1 is 1 by 2. x1 of 3 is 1 by 8. Okay. If I try to find out the output at this point, so 1 is coming here, 1 by 4 is coming here, 1 plus 1 by 4 gives us 5 by 4. So again at this point I need the input here as 1 and this is nothing but minus 1 by 4. So 1 minus 1 by 4 is nothing but equal to 3 by 4, correct. Now coming to this point, so here the input is 1 by 2 and from this stage we are getting it as 1 by 8. So 1 by 2 plus 1 by 8 gives us 5 by 8. At this point the input is 1 by 2 and the input here is 1 by 8, which is multiplied with minus 1. So what is the values here? It is 1 by 2 minus 1 by 8, which gives us 3 by 8. Okay. Now we are done with the output of first stage. Now I need to feed the input to second stage. The value of omega 4 power 1 is minus j. So what will be the values to the input of next stage? 5 by 4, 3 by 4, 5 by 8, and again this getting multiplied with minus j gives us minus j 3 by 8. Okay. If I find out the output at this point, the input here is 5 by 4 and input from this branch is 5 by 8. So 5 by 4 plus 5 by 8 gives us 15 by 8 and here the input is 3 by 4 and from this branch it is minus j 3 by 8. Again at this point it is 5 by 4 minus 5 by 8, which gives us 5 by 8, and at this point the output is 3 by 4 minus j 3 by 8. So this minus j is getting multiplied with minus 1, that gives us plus j 3 by 8. So we all know the output in order to find out DFT using DIT FFT will be in normal order. So this is equal to x of 0, this is equal to x of 1. So this is equal to x1 of 2 and this is finally equal to x1 of 3. Did I find out x1 of k? Yes, in the question they told us to find out the DFT of x1 of n using DIT FFT algorithm. So we found out x1 of k with the help of DIT FFT algorithm. Now let me tabulate that. So what is x1 of k? So x1 of k is nothing but equal to 15 by 8, 3 by 4 minus j 3 by 8, 5 by 8, and the last value is 3 by 4 plus j 3 by 8. So the second part is find the DFT of x2 of n using which algorithm? DIF FFT algorithm. Now let us try to find out x2 of k using DIF FFT algorithm. So I have x2 of n sequence. So let me draw DIF FFT algorithm butterfly structure for n is equal to 4. So which will have 4 lines and 2 stages again. Why 2 stages? If n is equal to 4 and if I express that 4 in terms of 2 power v, that will be equal to 2 power 2. So the value of v is nothing but equal to 2, which tells that it should have 2 stages. So now drawing the figure, the first stage, combine these two inputs, these two where this has to be multiplied with minus 1. Again these two inputs, this has to be multiplied with minus 1. So the second stage, it is here, combine these two and these two, here it should be minus 1, this two, these two, and here it should be minus 1. Coming back to the input where we find out DFT of x2 of n using DIF FFT algorithm, the input will be in normal order but the output is in bit reversed order. So let me write that. x2 of 0, x2 of 1, x2 of 2, x2 of 3, and the output is in normal order. So this will be x1 of 0, x2 of 0, x2 of 1, x2 of 2, and here it is the twiddle factor terms, omega 4 power 0, omega 4 power 1. Here it is omega 4 power 0 and omega 4 power 0. Now we are ready with the butterfly structure for n is equal to 4 using DIF FFT algorithm. Let us tabulate the values. So x2 of n sequence, all the samples are 1. So we get it as 1, 1, 1 and 1. So standing at this point, the input from this branch is 1, the input from this branch is also 1, 1 plus 1 is 2. Again at this point, the input is 1, here also the input is 1, 1 plus 1 is 2. Coming to this point, the input from this branch is 1, the input from this branch is minus 1, that gives us 0. Again coming to this branch, the input is 1, this is multiplied with minus 1, 1 minus 1 is 0. Okay. Now moving on to the second stage. So the input here is 2, 2, 0 multiplied by this is 0, 0 multiplied by this middle factor term is 0. Again let me try to find out the output. So here both the inputs are 2, so 2 plus 2 is 4. At this point this branch is giving us input 2 and this 2 is multiplied with minus 1. So the value at this point is 2 minus 2, that gives us 0. Here in the next path the outputs are 0. Why the outputs are 0? Because the inputs are itself 0. Now multiplying 0 with omega 4 power 0 is 0. Again 0 with omega 4 power 0 is 0. So we found out x2 of k. What is x2 of k? It is nothing but equal to 4, 0, 0, 0. So let us tabulate that. So x2 of k is equal to 4, 0, 0 and 0. So we completed the first part, that is compute the DFT of x1 of n by DIT FFT algorithm and that of x2 of n by DIFFT algorithm. The second part is using the above results evaluate the circular convolution of x1 of n and x2 of n. So now let us try to find out the circular convolution of x1 of n and x2 of n. From circular convolution property, what we know? Property. Let me term the circular convoluted sequence as x3 of n, which is equal to x1 of n circular convolution with x2 of n. From circular convolution property, x1 of n circular convolution of x2 of n, to this if we apply DFT, the resultant will be x1 of k into x2 of k, correct? Which is nothing but if I apply IDFT to this, we will get this, which indirectly tells it gives us x3 of k. Now what I need to do? I need to multiply x1 of k and x2 of k, then I need to apply IDFT to find out x3 of k, which is nothing but the circular convoluted sequence of x1 of n and x2 of n. Now if I combine x1 of k and x2 of k, so x1 of k into x2 of k. So the first sample of x1 of k is 15 by 8 into this first sample of x2 of k is 4. The next one is 3 by 4 minus j into 3 by 8 into the second sample is 0. So the next here it is 5 by 8 into 0 and again it is 3 by 4 plus j 3 by 8 into 0. So this is x1 of 0, x1 of 1, x1 of 2 and x1 of 3. This is x2 of 0, x2 of 1, x2 of 2, x2 of 3, which we computed few minutes before. Now if I find out the resultant, multiplying these two gives us 5 by 2. So this is multiplied with the 0, this is also multiplied with 0, so this is also multiplied with 0. So all the three terms tends to 0. Now what did I do? I found out x1 of k into x2 of k. Now what I need to do? If I apply IDFT to x1 of k and x2 of k, that gives us x3 of n, which is nothing but equal to x1 of n circular convolution with x2 of n. Okay. Now keeping this in mind, with the help of the algorithms, fast Fourier transfer algorithm, we will try to find out x3 of n. If I draw the butterfly structure, so since we are finding out 4-point IDFT, so we will be having 4 lines, and again if n is equal to 4, we will have how many stages? We will have 2 stages. Here the input is in normal order. Okay, I am terming this this as x of k so that it will be easy for tabulating, and the output will be in bit reversed order. So this will be x3 of 0, x3 of 2, x3 of 1, x3 of 3. Why am I taking it as x3? Because we have considered the circular convolution of x1 of n and x2 of n and x3. So I am writing the output in terms of x3. If I complete the butterfly structure, so combining these two inputs, minus 1, here it is omega 4 to the power of 0, omega 4 to the power of minus 1, minus 0 and minus 1. Again completing this, combining with two inputs and multiplying minus 1, combining the inputs by adding and subtracting. So finally this will be omega 4 to the power of minus 0, here also it is omega 4 to the power of minus 0. At last I need to divide the sequence by n. Okay. So what is x of 0? So it is 15 by 2. X of 1 is 0, x of 2 is 0, x of 3 is 0. The same sequence I have tabulated it here. So what is the output at this point? 15 by 2 is coming here. The other input is 0, which gives us 15 by 2 only. At this particular point, both the inputs are 0, so the resultant is also 0. At this point, one input is 15 by 2 and the other input is 0, which gives us 15 by 2. Here the resultant is 0 because both the inputs are 0. Moving on to the input to second stage. So 15 by 2 remains as it is 0. 15 by 2 multiplied with 1 gives us 15 by 2. 0 multiplied by anything is 0. So if I find out the output at this particular point, it is 15 by 2. Here it is 15 by 2 minus 0, that also gives us 15 by 2 only. At this point 15 by 2 plus 0 gives us 15 by 2. Again here 15 by 2 minus 0 gives us 15 by 2 only. Multiplying 15 by 2 with the twiddle factor term, that is omega 4 to the power of minus 0, which is equal to 1, gives us 15 by 2. Similarly 15 by 2 multiplied with omega 4 to the power of minus 0 gives us 15 by 2 only. At last what I need to do? I need to divide this by n. So if I divide this by n, what is the value which I am getting? So that will be equal to 15 by 8, 15 by 8, 15 by 8 and 15 by 8. So finally we got the output, that is the circular convoluted output of x1 of n and x2 of n. So let us tabulate this. Therefore x3 of n, which is equal to circular convolution of x1 of n with x2 of n, is equal to 15 by 8, 15 by 8, 15 by 8 and 15 by 8. So this is how, with the help of both DFT and IDFT, we can compute the circular convolution of given sequence. So in some question they may change like this, that is compute DFT of x1 of n and x2 of n using DIF FFT algorithm. Using the above results, evaluate the circular convolution of x1 of n and x2 of n. Or they may tell you to compute the DFT of x1 of n and x2 of n using DIF FFT algorithm, and later they may tell you to find out the circular convolution of x1 of n and x2 of n. Like this, they may interchange the combination and they may tell you to find out the circular convolution using DIT FFT algorithm and DIF FFT algorithm. So this was all about module number 2, where we can use DFT in linear filtering. So the next concept we saw was the classification, where we saw why we call it as radix 2. In radix 2 we studied two categories, that is DIT FFT and DIF FFT. So we saw the derivations related to DIT FFT as well as DIF FFT. With the help of these two algorithms, we tried to find out DFT, IDFT as well as circular convolution. So this completes module 2. Thank you for today's session.